All right, let's look at our third energy level because it's a little bit different. If we look at our periodic table, when we go to the third period, we still only have 6 elements in our third period. But we said that in the third energy level, there are s, p, and d orbitals. So this helps to explain why we said before when we were doing our Bohr diagrams that there are either 8 electrons, or if we fill in 2 electrons up in the fourth energy level, then we can fill in up to 18 electrons in our third ring. So let's look at that again. The third energy level contains s, p, and d orbital types. S orbitals can only contain 2 electrons. P orbitals have 3 orientations, so they contain 6 electrons. D orbitals have 5 orientations, so they contain 10 electrons. So if we look here, what we fill in first, we see we go 1s2, 2s2, 2p6, then we would go 3s2 with our sodium and magnesium. Then we would go over here where we're filling in the p orbitals, so our 3p6, and that would then, we would need to go into the fourth period. So we get up to 3p6, and that would be the same as our argon configuration. But then we're going to have to find our 3d orbitals later. So let's go down to our fourth period now in our periodic table. If we go into the fourth period of our periodic table, we can see that we hit our s orbitals first, and then we hit some d orbitals. The first time that we hit those d orbitals has to be the third energy level. So if we have f orbitals in the fourth energy level, we haven't hit our f orbital yet, but we have hit now our 3d orbital. So when we go and we fill in our electron configuration, again, we follow and we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then we hit our d orbitals here, and this must be the third energy level, d orbitals, where we can fit 10 electrons. Then we would jump up and we go up into our 4p orbitals with 6 electrons. So this now would be our electron configuration for krypton. Okay, so hopefully you are seeing how we're using our periodic table to understand and write our electron configurations. Okay, so we're going to go into our fifth period here now. When we go into our fifth period, same thing, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, that must be the fourth energy level, d orbitals with 10 electrons. And then we go 5p6. So here now, this would be xenon. So now, finally, we're going to get to jump into our f orbitals soon here. So let's go look at our sixth period. For the sixth period, we have our s orbitals first, but then we've got a break where we go down into our f orbital block. Our f orbitals, we go 6s2, and then we drop, what was the first energy level that had f orbitals? That must be the fourth energy level, f orbitals, that can fit 14 electrons. So we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, and then we get to go into our F block, so that would be 4f14, 5d10, 6p6. This would now be radon. All right, last one, our 7th period. With our 7th period, we do the same thing. We have our 7s2, then we drop into our F block, so that must be our 5f14, 6d10, and 7p6. So our full electron configuration, the highest electron configuration with the most electrons that we have seen, would have all of these electrons in exactly this order. We can use this order to fill in our electrons all the way starting from the beginning, as long as we count our electrons appropriately, or we can understand how our periodic table can be used as well. I'd recommend using our periodic table. So let's go through an example. We have gold, but it is a +1 charge. If we have gold as a +1 charge, we would have 79 electrons, but then we only have 78 to fill in. With our 78 electrons, we have first our 1s2, that's 2 electrons, 2s2, that's 2 more, 2p6, we're up to 10 electrons here. I'm going to write that just so that I remember. 3s2, 3p6, that's 18 now. 4s2, 3d10, 4p6. Well, if I add that up now, that would be 34. 5s2, 4d10, 5p6. So if we add up that, 36, 46, 54, 6s2, 4f14, we have 8 electrons that would be left over here. That's 70, and we said that we have 78 electrons total. So rather than having a 5d10, exactly as we had up there, we only have 8 electrons that are left, and so they must be in the 5th energy level d orbitals. So if we add up our exponents, all of them add up to our 78 total electrons. Again, we can use and follow our periodic table across to know our order here. Okay? All right, you guys have some practice here now that I think we can do all together.